In this video, I'm going to discuss derivatives of trig functions. Now, fortunately for you, the derivatives of trig functions are given in the formula booklet and they're listed here. So what we plan to do is to apply these derivatives of the given trig functions to answer these questions. So in number one, we are required to find the derivative of um, y is equals to x and x. So because this is a product of two functions, we shall apply product rule. So dy over dx will be equal to x multiplied by the derivative of sine x plus sine x multiplied by the derivative of x. Now the derivative of sine x is cos x, so this will be x cos x plus derivative of x is 1, so this will just be sine x. In the second question, we have the derivative of 4 multiplied by the tangent of 3x squared. So this can be written as 4 multiplied by the tangent of 3x squared. So one thing that you may notice here is we have a function inside this function and we have another function inside the inside function. So we shall apply chain rule twice. So dy over dx will be equal to, we start with outside, so that will basically be 4 multiplied by 2. And then the derivative of course, if you bring 2 in front, that means you reduce the power by 1, so you'll be left by tan 3x to power 1. So this will be tan 3x to power 1. And then now the derivative of tan is secant x squared, so that will be secant 3x squared. But now the derivative of 3x is 3, so this will be multiplied by 3. And now if we put all these things together, we shall end up with 24 multiplied by tan 3x multiplied by secant of 3x squared. And that will be the derivative for that function. In number 2, we shall work it the same way. So here we have cosecant of 3x. Now here we have a function inside another function. So we'll apply chain rule. So dy over dx will be equal to the derivative of cosecant is negative cosecant of x multiplied by cotangent of x. Yeah. So, but what we can do here is let's first of all start with the inside. So let's start with the derivative of 3x, which is just 3 multiplied by the derivative of cosecant, like I've said, is negative cosecant of 3x. Yeah, because our x is 3x multiplied by cotangent of 3x. So that will be equal to negative 3 cosecant of 3x cotangent of 3x. Right, for 2b, we have cotangent, square root of cotangent of x over 2. So I'm going to rewrite this such that instead of having the square root, you can have something to the power half. So this can be written as cotangent of x over 2 to power a half. Now here again, you can notice that we have a function inside another function. We have cotangent, and then we have x over 2. So what I plan to do here is to apply again chain rule twice. So dy over dx will be equal to, so we start with outside, so we bring a half in front, so that will be a half into bracket cotangent of x over 2. Okay, because the power reduces by 1, so that will be to the power negative a half. Multiplied by, now the derivative of cotangent is negative cosecant x squared, and our x is x over 2, so that will be equal to negative cosecant uh, oops, cosecant of x over 2 squared. And then this will be multiplied by the derivative of x over 2 will be a half. So if we simplify this together, that will be equal to negative a quarter multiplied by cosecant of x over 2 squared multiplied by cotangent of x over 2 to power negative a half, and that will be the required solution. Okay, number 3, we have the derivative of x squared sine 2x. Now, of course, basically by looking at this is a product of two functions, so we apply product rule. So dy over dx will be equal to x squared multiplied by the derivative of sine 2x plus sine 2x multiplied by the derivative of x squared. Now here, just remember here we have a function inside another function, so we'll have to apply chain rule when we differentiate that. So that will be equal to x squared multiplied by the derivative of sine is cos, so by the derivative of 2x is 2, so 2 multiplied by cos 2x, because you do inside and then outside, so inside is 2, outside cos sine, derivative is cos. And then here it will be sine 2x multiplied by 2x, because derivative of x squared is 2x. And then grouping things together, so we'll have 2x squared cos 2x plus 2x sine 2x, and that will be the required solution. Okay, for part B, we have y is equals to e to the power of 3x minus 1 over cos x. Now here, because we have a quotient, we are going to apply quotient rules. So this will be over u. Uh, well, let y be equal to u over v, where u is e to power 3x minus 1 and v cos x. So dy over dx by, of course, by quotient rule, dy over dx will be equal to cos x multiplied by the derivative of e to power 3x minus 1 minus e to power 3x minus 1 multiplied by the derivative of cos x, all this over cos x squared. Okay, and now here we have to find the derivative of e to power 3x minus 1. Now here we'll apply chain rule because that's the power there. Yeah, so inside outside. So here we'll have cos x multiplied by, if you find the derivative of 3x minus 1, that will be 3 multiplied by, of course, everything, which is just 3x minus 1, minus e to power 3x minus 1 multiplied by derivative of cosine is negative sine x. All this over cos x squared. Okay, and this will be equal to, so this will be 3 e to power 3x minus 1 multiplied by cos x. negative and negative, that will be a positive, e to power 3x minus 1 multiplied by sine x, all this over cos x squared. And that will be the required derivative for this question. Okay, moving on. Part C of this question. We have a product of two functions, which is ln x squared plus 1 and tan x over 2. So what you're going to do here is to apply, basically to apply product rule. So dy over dx will be equal to ln x squared plus 1 multiplied by the derivative of tan x over 2 plus tan x over 2 multiplied by the derivative of ln x squared plus 1. All right, so one thing you can notice here is that we are going to apply chain rule in each of these cases because we have functions inside the given functions. So the first case, this will be equal to ln x squared plus 1 multiplied by, now the derivative of tan is secant x squared, so this will be secant of x over 2, and then derivative of x over 2 is a half because you have to do outside and then inside, plus here we have tan x over 2 multiplied by, so here we have derivative of ln is just 1 over x, under x is x squared plus 1, so that will be 1 over x squared plus 1 multiplied by the derivative of inside, which is highlighted here, will be 2x. So if we put all these results together, we have ln x squared plus 1 multiplied by, actually we have a half, so let's just have a half in front. So we have a half, and then let's have the second of x over 2 squared multiplied by ln x squared plus 1 plus, here we have 2x over x squared plus 1 multiplied by tan x over 2, and that will be the required derivative for that function.